Our presentation today is on the Twin Ports interchange, so the TPI construction staging and maintenance of traffic. This was a $343 million multi-year reconstruction project that reconstructs the I-35, 535, and US 53 interchange, and then the I-535 and Garfield Avenue interchange up in Duluth. The project includes improvements to address and correct freight and safety issues caused by structural and geometric deficiencies. The project is being delivered via the construction manager general contractor alternative delivery method. Brett and Nicole are our presenters today from Alliant, so thank you. Brett is a PE and is a principal at Alliant Engineering with 22 years of experience, specializing in maintenance of traffic and construction staging, as well as roadway design and traffic engineering. Brett has spent most of his career developing innovative construction staging solutions for complex high volume interchange projects throughout the states of Minnesota, Utah, and Colorado. Nicole Wilson is also a PE and is a senior professional engineer at Alliant with 8 years of maintenance of traffic, construction staging, and roadway design experience. Nicole has led the maintenance of traffic detail design effort on complex projects, including the TPI reconstruction, the I-35W River Bridge design build, and West Davis Corridor in Salt Lake City, Utah. And with that, I will turn it over to Brett and Nicole.
All right, thank you very much, Justin. Yeah, I guess you've already done the introduction, so I will share my screen. So first off, hold on, let me share my screen first. All right, you should be all seeing it. Do you see it, Justin?
Yep, we can see it.
Good. First off, I want to thank my parents for coming to this thing. It was probably a little awkward with the breakout session, so whoever they ended up with, hopefully they were all right, and hopefully they were able to navigate back to this. So they've been wondering for 22 years what I do for work, and this is probably the best way to show them it. So, all right, so let's do this. So let's see. So are you still seeing my screen, Justin?
Yep, we can still see it.
Okay, I lost my green square around it, so apologize for that. All right, so we're going to try kind of treat this like an MOT task force meeting. So if you've got questions, anything arises, just feel free to yell them out as we go through it. But we're just going to run through the TPI project. One thing to keep in mind with this presentation is that we're going to kind of focus on the process we use to get to our preferred alternative, and not really go into a bunch of the different alternatives that we looked at. So it's a little bit different than a normal task force meeting. So we're using Bluebeam instead of a PowerPoint, just so that I can go through a lot of different slides quickly. So with that, I will go to the next one. So presentation outline, here's what we're kind of going through. We'll do a project overview. We'll go through what CMGC is, just to kind of give people a 5-minute update on that or what it is. We're gonna go through our tools that we used to develop the alternative analysis, pros, cons, matrices, construction cost estimates, detour reviews. Then we're gonna go through the final staging so everybody knows what they're gonna be driving through for the next 3-4 years up in Duluth. And then we'll go through some Q&A if there's any that arise after that. So with that, Nicole, do you want to share your screen and go through what the actual final product is going to look like?
Yep. Once you're done sharing, there we go. All right. Okay, so this is our final roadway layout that was produced by the project team for the Twin Ports Interchange project. Just to get your bearings on where we're at, if I look at this map over here, this is the aerial bridge right here in Duluth. The lake is on the right side, the hill is on the left side, and then highlighted in red is where we're talking about. So it's, you're driving up 35 towards the north. This is just prior to entering the Duluth area. The limits of the project extend from just south of the 27th Ave Bridge. It does not include the ramps on the south side of the interchange. It includes the 27th Bridge, a full reconstruction of the main interchange. If you see on this layout, we've been through many iterations of this project due to funding. And so this layout actually shows a temporary bridge connecting between our main interchange, which is called the Green T, and Trunk Highway 35 going up the hill. We recently just updated this or revised this again to not include a temporary bridge, but instead include final construction of 53 up until the limits that you see at the top of this layout. So that's recent changes as of a month ago. And then, so that's the limits of 53 coming down 535 towards Wisconsin. It has construction all the way down just past the interchange, and then not shown on this layout, there's the Garfield Ave interchange right when you get over the Blotnick Bridge. And then 35 construction ends just before Garfield Ave. So that's, I guess, the gist of the project. There's some, right now, everything today is a bridge, essentially. And even 35, you might not realize it when you're driving through there, but there's 2 low-level bridges that traffic is driving on 35 itself. There's a massive, what we call a hump, very engineering term-esque hump in the roadway just prior to the interchange from an old railroad crossing. And so our project removes that hump for site distance issues. We take out all of these bridges in this infrastructure and we put in a load transfer platform, which we'll get into a little bit, and a roadway pavement surface rather than a bridge, and reconstruct the rest of the bridges in the area. So that is a high-level overview of the project. Back to you, Brett.
Okay. All right. So just a quick little run through of like what is CMGC. So CMGC truly stands for Construction Manager General Contractor, and just super high level, what it really is that so like design build, the contractor would work for the DOT and the designer would work for the contractor. In the CMGC world, the contractor and the designer are both on staff but work directly for the DOT, which allows the contractor to be involved in the process from the very start to provide construction input, staging, scheduling, cost estimating, all that stuff as the design develops. But ultimately the designer still does, they report and they're contractually obligated to the DOT, and not, there's really no direct connection between the contractor and the designer. And then once it actually goes to construction, it's kind of like a more traditional delivery where it's a bid set with quantities, and the contractor just takes it and goes forward with it. Some of the high level elements of it, like I said, the consultant produces plans, specifications, and PS&E consistent with design, bid, build. There are 3 independent cost estimates that are going on throughout the whole process. There's a contractor one, so up on TPI it was Ames and Kramer, so they generated a cost estimate throughout the whole thing. There's an independent cost estimating team that does another estimate that's shared, and then there's an engineering estimate which is done within the DOT, and that's the top secret one. So really it allows us to kind of have multiple cost estimates going on that are shared and discussed throughout it, but at the same time there is an engineer's estimate that's behind the scenes that's being worked on in a way to kind of make sure that you still get a competitive bid, even though there's only one contractor bidding the project. So it's an open book process. There's still 30, 60, 90, 95% milestones. There's design workshops throughout the whole thing to make sure that everyone's on the same page as far as what we're building, why we're building it, where is the risk, where are the unknowns, so that everyone can kind of take care of those risks and work on getting the unknowns down to nil, so that helps the cost come down. Like I said, there's risk workshops. And then after each of those submittals, there's like a variance report. So that what it does is it compares the contractor's estimate, the ICE estimate, and the EE. And it notes if the contractor's estimate, the ICE are outside of 10% from the EE, so that we can kind of identify those elements that might be an issue, or those cost components that might need more discussion. Is the contractor assuming more risk in those areas than they should be? Is the engineering estimate not out of line for those? So just to kind of I always look at it as a upside down cone. At the beginning, everybody might be pretty far apart with costs, but by the end, after you've gone through a 60, 90, 95, you should be pretty dang tight as far as what we're bidding, and make sure that we're all on the same page. So There's price reconciliations. At the 95%, our plans still do go to pre-letting, just like a normal design bid build would, so that so that gang can have a chance to review it, make sure it's biddable. It does go out to bid. At that point, CMGC, contractor, and the ICE are the only ones that review it and provide independent bids. There's then a bid analysis, which compares all three of the bids. If the contractor's bid is within 10%, it can be awarded without justification. If it's greater than 10% or lower than 90%, then the ICE and the EE prepare a letter describing the findings. They can then go into a bid analysis meeting to determine, why are we still far off? Like what came up that threw those out of whack, because they should have at that point been in line. And then they can either bid it again to that same contractor and keep on working on that to get down to that agreed upon price. Or if reconciliation is not possible, the DOT, because they've got a plan set that is that's been through pre-letting and everything like that, it can go out to general bids, and they could just walk away from the general contract or the construction manager, and the construction manager could still bid the project and be competitive against other contractors, but typically they would not want to go that route. So pros, the reason that CMGC is good is that it really does help us lock in our guaranteed max price, because the contractors involved, they are working on they're working on the estimates throughout the whole thing, so that the DOT has the ability to pull off elements of the project. If it doesn't seem like if the cost is getting too much, you can defer areas or make different work packages. In general, there's fewer change orders because the contractors involved in bidding the project is involved in the development of the plan, so they kind of know what's going on. Obviously, project schedule control, they work on the staging with the designers to help figure out how this thing's going to all play out in the field. You can do early work packages, which is what we did on the TPI project. We were able to break out the 27th Avenue Bridge and the hump removal earlier than everything else, so we were able to continue design while the contractor got bidding and working on the first elements. And then ultimately the owner does retain control, since the design is, we have a contractual relationship with the DOT as the designer. The DOT can still decide what's in that plan set and what it ultimately looks like. Even if the contractor doesn't agree, it's still MnDOT's plan set. Cons, design compromises. You do have the contractor in the room and talking, so maybe things get pressured into a way that everyone didn't really want it to go, but it makes sense for the project. There's the idea that there's potentially no competitive bidding. With the whole 3 estimates, it does take that and mitigates that risk, but it isn't a competitive bid against a bunch of other contractors. Culture change. CMGC is still relatively new in the state of Minnesota, so it's just a different feeling when you're sitting with in a room with a bunch of contractors and designers and DOT people figuring out how this relationship works. And then severability, how do you kind of like walk away from the project? If you've got different work packages, you got to make sure that, if work package 1 is being delivered by the contractor and they still need to bid work package 2, how do you make sure that if you can't come to a common agreed upon cost in work package 2, how do you sever it so that you get to go out to bids with another contractor while the first contractor is still working on work package 1? So now the question is, how did we develop, using the CMGC process, how did we develop the staging for the TPI project? As Nicole said, this job was very different than other jobs that we've worked on, in that this intersection was extremely complex and it was all on structure. So like 35 itself through there was on low level bridge structures. There was all the ramps were on structures above. It was just this big, they called it the can of worms for a reason. So, and then really, if you look at, there's really no good, routes to the west, and then to the east is the bay. So, and you've got 535, which is part of the project that goes over to Wisconsin. So it's like, how do you develop detours that works for this when you have to close a bunch of ramps and main lines and all that type of stuff? So what we did is, step 1, we just started to look at the project and tried to figure out, what's the overall staging approach we wanted to use for the job. So we just initiated that with a couple different staging alternatives. The 3 that we really looked into the most, and on here I'll show you a couple of them. So we really looked at option 1, which was a 3-lane section with a reversible barrier. Option 2 was a single lane in each direction for an extended duration of time. Then option 3 was trying to maintain 4 lanes of traffic at all times, so 2 northbound, 2 southbound on 35, and using bypasses and local roads and stuff like that. So to start it, we just created a pros and cons matrix. The nice thing is the contractor was involved, so we just created a spreadsheet that we bounced back and forth between contractors and designers and the DOT to just enter what they saw as pros and cons for everything. As you can see, like option 3 had, so this is me from the design side. Ben Levin was with Ames. Steve Kaldenbach was with Kramer, so he was mainly looking at the bridges. Ben was looking at most of the grading type things. Then we got into, so Caitlin was with MnDOT, so she was looking at schedule, project, public affairs type stuff. So you could just see that a bunch of people were jumping in it and developing those pros and cons. So it's a pretty common thing to do on jobs. We then also did just a quick cost estimate or cost comparison. I'll say it was not an estimate. It was more of a comparison where we just at a very high level, I could zoom in. So we just looked at, so we eliminated option 2 really quickly, saying that 1 lane in each direction for multiple years up in Duluth was not going to fly. So let's just get rid of that. So now it was reversible barrier versus 4-lane section with bypass. So really we just looked at the very big ticket elements. So on this job, we looked at it and we were looking at movable barrier by itself was coming in at $4.6 million. And then we looked at over at option 3 and we're seeing that our temporary paving quantities and stuff like that were coming in at, $1 million. So it became pretty evident that the bang for our buck was temporary paving, bypasses, and maintaining 4 lanes. It was better for traffic. It was better for the cost. So we moved off of that pretty quick and honed in on what we wanted to do for the job. That point we went into the detours, and that was an uphill battle. So we used a lot of different tools to kind of figure out and hone in as to what detours we were going to use, what was going to work through this system. The first thing we did was we just kind of looked at the overall, so we came up with our preferred staging alternative and started to say, okay, if we close things, what does it look like? So we just in a nice simple spreadsheet, we just worked out, what are the different movements we're talking about in this intersection? And then what are the closure durations for each one of them if we use that staging? Are they full closures? Are they partial closures? Are they single lanes? Just to kind of see how everything just looks graphically. Are they all lumped up in a certain stage? Do we need to start pulling them or pushing them apart? So that was that. We then took that into this nasty thing, which is so we called this our detour review. This was our first stab at just saying, what are all the movements that need to close and what are the potential detours? So as you can see, we went through and just in each stage, we looked at different ones that were possible. So, here's one movement, 535 southbound to 35 southbound. So we looked at, past detours that have been used by the project were these, stage 3, and we put some comments. So for each of these detours that have been used in the past, we put in stage 3, here's the comments. In stage 5, here are the comments to kind of just write out what our thoughts were if they conflict. So like in this case, green meant it worked, it should work. Green is it should work, doesn't, and the other ones are like, okay, this one no longer works because this is closed concurrently. So it just started letting us hone down on what don't work, what does work, what might work. Then we also drew up some other potential detours. So these were past detours, these are potential detours, and again, went through kind of like what would work, what might not work. After we did that, you can just see the amount of detours that we looked at were many. So at some point, you just got kind of numb to them. We then took that and worked with the DOT very closely to figure out what were the preferred ones, what made the most sense. And then we created this. So we just kept on, honing down to what we wanted to really be. So at this point, we were down to this. If this is our preferred staging alternative, here's our preferred detours and how they still jive now more in a timeline phase, just to make sure that they still work. And in this case, green was ones that we all agreed on. We're moving forward with. Black, we were still kind of discussing a little bit more to make sure that was what we wanted to do. To help it even more, we generated a staging, or I'd say a big, large scale layout of the area. to just discuss and identify, what are these detours that are going concurrently look at. So each stage, so stage 2, stage 3, all 6 stages had a layout where we drew on every single one of the detours and movements to make sure that, how are they conflicting? Are they kind of honestly just, are we spreading the wealth around, or actually spreading the pain? So making sure that different routes had different detours going on them, and we didn't have everybody using the same route. So in this case, and you can kind of see if you look through it, there's 2 different routes that are using Garfield, one route using 3rd, another route using Superior, another route using 40th. There's a bunch of routes we decided as a team that it made sense to use the Bong Bridge down to Wisconsin for multiple ones to just keep them out of the interchange, because, it's going from a system to a system interchange. So that made a lot of sense. And the other one that we really arrived at was to send several of them up to, Central Entrance and Mesaba to kind of just circumnavigate the project too. But in this phase, there were still only 2 that were using that. So we tried to do our best to kind of spread people around, to also make sure we didn't overload the amount of detour traffic signs there were along any routes. We didn't want 12 different detour route signs at an intersection. So tried to spread those out. So now the question is, okay, how did you take all this pre-work and take it into the actual project and the plans? We did something a little different there too. So instead of doing a detour layout per stage, we decided to do a detour layout per, roadway closure or ramp closure. The reason we did this was twofold. One, we felt it was nice. So as you can see here, like detour layouts. So for each stage, we then, so I guess go over here first. So these are our detour layouts. So as you can see in this is from work package 3. We had 37 different detour layouts for different closures. We then went and took these detour layouts and put them into each stage and each phase and said which ones were applicable. We thought this had a lot of value in that the contractor, once they're out in the field, can say, okay, I've implemented layout 3, and that stays into effect from stage 3, phase 2, all the way to stage 5, phase 4. So I don't need to go and screw with that. I can leave those signs up, and they could do that with a big bunch of them, and then really look at, they could go and say, so for stage 4, phase 2, there's one that's no longer necessary. They could go and pull that plan sheet out and remove those signs. So just kind of gave it a way to boil it down to not being overwhelming. It also honestly really helped the detail checking process, because trying to follow 12 different roadway closures through a plan set was tough. So we then, as an example, so like this is what we boiled it down, like here's one ramp, the northbound entrance ramp from 27th is closed. Here are the detour signs for that one ramp closure. So, and this was used from stage 3, phase 2 and stage 5, phase 4. So it was a way to kind of just boil this whole thing down from something that was very unmanageable to something that was a little bit more manageable. So that is how we kind of went through the whole detour effort for this job. I will turn it back over to Nicole. She's going to start walking you through the first portion of the actual construction staging that we arrived at for the preferred alternative. Nicole?
I'm coming. All right, this is the fun stuff. So ultimately, what I'm going to walk through is from the beginning of construction, which started back in the fall of 2020, up to where we are today. And then Brett will take the future from there on, what we just hashed out with MnDOT and the contractor last month. So here's starting at the very beginning of the job. You can see here's the main interchange, bridges galore. Basically our stage 0 was prep work to prepare for shifting traffic when we get to stage 1 and start really building our job. So starting in these layouts, north is up and to the right. So at the bottom of the screen is the lake. At the top of the layout is the hill in Duluth. And then this little cutout over here is Garfield. So nothing's going to happen at Garfield right now, but when we get into Brett's, a little bit more work will be happening at the Garfield interchange. So starting at the very south end of the job in stage 0 phase 1, we just did prep work. We built a crossover knowing that traffic would be flipping back and forth between northbound and southbound several different times in order to complete the permanent construction. So we built a crossover, we did some temporary widening prep work. During this stage, we had traffic down to a single lane in northbound and southbound directions, just in this area. The remainder of the job, all of the existing traffic movements were open. Then when you get to stage 0 phase 2, this is our second stage of prep work. So all of the inside work is completed. Now we shift traffic in and we build the outside. So we built a temporary ramp from 35 southbound up to 27th Ave, which I'll have some fun pictures in the next sheet to show you what that looks like out there in the field. And then also we did temporary widening on the northbound outside edge. This was a massive 1 to 3 slope chasing down a hill for quite a ways. So we ended up having to protect this with temporary barrier. We just made a judgment call that if someone accidentally goes off the road, we want to make sure that we, I guess, don't let that happen because they would get a little trapped down here by the railroad. So we did temporary widening on the outside of northbound. And we put in a crossover up at the north end as well. Once again, to flip traffic north and between northbound and southbound. Okay, so our prep work is done. Now we get into the fun stuff and actually start building some permanent construction. Something really cool that I've enjoyed for this project is MnDOT has a drone pilot up in District 1 who has been flying the job and taking pictures and sending them to us throughout many of the stages of construction, which has been really awesome to see. So we can, from an aerial view, see our work in action. And it's been fun to watch it all kind of play out and see the contractor pretty closely following our staging approach. So here down the south end, traffic will now, this is in stage 1, this is where we reduce traffic to 1 lane in each direction on northbound and southbound. So Brett said for this option, which was option 3 of our giant, all of our different alternatives, for this option, we still had to go down to a single lane in each direction, but for a limited duration. So it's not for the whole entire job. It's just for stage 1 that we needed to, through the 35 corridor, reduce to 1 lane in each direction. So at the end of this view up here, you can kind of see it. So here you have traffic. Southbound is over on northbound's pavement, northbound squeezed down to 1 lane. You can see we're starting to demolish the bridges over 35. Here's those low-level bridges that we were talking about, right? So this is all looking to the north. This is northbound on a bridge today. Here's southbound. We are building a proposed box culvert. So we had a box culvert, very large box culvert going in underneath 35 northbound and southbound. We built it in 2 different stages. So we built the west side and the very far east side together in stage 1, and then when we get further in staging, we build the connection between the 2 when we could get at the middle section. So we kept the existing right here where my pointer is at. You can see we kept the existing box culvert and we utilized it while we were building the proposed box culvert. So this kind of gives you a little bit of a scale of, here's that hump we were talking about removing on the right side of this picture. And then we had a box culvert going in. We had a 1.5 to 1 slope coming off of the existing pavement to come down to build the box culvert, temporary shoring. It was some pretty intense analysis and staging. All right, I got ahead of myself a little bit. So if I back up a little bit, we're from the south, we're shifting all traffic over to northbound and head to head, separated by barrier. We're building the 27th Ave bridge, which you can see completed right here. So traffic's once again over on northbound. We're completing the bridge. During this stage, to build that bridge, you can never place girders. You don't want to place girders over live traffic, and you don't want to pour your final bridge deck over live traffic. So that's why we built 2 crossovers in this area to flip traffic between northbound and southbound a number of times in order to complete that bridge construction. So we'd flip them over to southbound, flip them back over to northbound, and then vice versa, flip them over to build the girders over northbound, cross them back over once they're on the other side of the bridge. Then, so all traffic is on northbound. We are constructing southbound in this stage. We, like I said, roadway removed a big hump. Here's what the hump looked like. So green in this profile, this is the proposed roadway profile. Green is the existing ground line. And this is where that bridge, the existing Lolova bridge, splits off, which is why the ground drops off. And then red is our permanent finished grade. So roadways finished grade. So from the ramp nose of 27th, right here, up to the final green T bridge, we had roughly 10 feet, vertical feet of cut. When you have a lake on one side, a hill on the other side, you don't really have a lot of options other than to try to maintain traffic, right? So that's really what narrowed us down to the head-to-head situation on northbound and building a temporary pavement structure on southbound for future traffic. With that, you can see in this photo also, we planned out a temporary bypass. So in the next stages, I can kind of get into what the bypass looks like, but we built a temporary bypass connecting between that southbound structure, temporary structure, underneath all of the in-place bridges, we thought. So it was going to connect between Lower Michigan Street, weave through all kinds of existing bridge piers and connect it back up to that southbound temp structure. The design of that bypass was quite interesting because, like I said, our intent was to maintain traffic. So we had the 535 and 53 bridges still open to traffic. So we squeezed this bypass through all of the existing bridge piers for the bridges that remained active. In the end, MnDOT decided, let's just close these ramps and 535 and 53 sooner and construct this bypass a little differently. So that's what ended up in the field, and you'll see it in the drone photos, how it doesn't look as much like a bubble around. So continuing through the corridor up 35, once again, traffic still on northbound, all the way up until the northernmost crossover where southbound is back on southbound's pavement. We're building that bypass all the way along a lower Michigan Street. So this is a local street that eventually we are going to take all of our southbound traffic and put them on. I don't know if any of you have driven this, but you don't really realize it when you're up there. The fact that you're coming off of a trunk highway, coming down onto a city street and driving on a city street for the majority of the 35 project. So it was executed pretty well if you can't really tell when you're driving it. And then I just included another picture of our traffic split. So here you can see traffic this picture is looking towards the south. So here's the main interchange. This is the Garfield Ave bridge over 35. So southbound through traffic has shifted over onto northbound side. And southbound, we still have lanes open for ramp access only. So we caught everyone that was wanting to travel through on 35 at the crossover, and this we signed very heavily for ramp access only. Another interesting thing, so when traffic did go down to one lane in each direction, we made the decision to include intelligent work zones and a queue warning system. So on the south end, that was pretty simple. There was not a whole lot happening south of Duluth. So trying to fit in that system extended for miles south of the project. But we had more of an issue, a struggle on the north end of the job, because if you look in this Google Street View shot, a lot of the 35 corridor north of our project has retaining walls on the north side. So when you go and you start looking at that intelligent work zone queue warning system, and you realize that some of these temp signs are 6-8 feet wide, and you're trying to squeeze it onto this shoulder, that's just not going to work. And so we worked very closely with MnDOT to implement a temporary overhead sign structure. So we shifted all of our traffic put in this big overhead sign structure to mount that sign on during the one lane on southbound. So this detail for the temporary overhead sign structure was not yet signed or approved by the MnDOT standards unit. And so there was a lot of back and forth to finalize that detail for this project. Okay, that's stage 1. Then we go into stage 2. So in stage 2, northbound is still in the same location as, this is stage 2, phase 1, I should say. Northbound is still in the same location as they were in stage 1, and we flipped southbound onto the temporary pavement. During stage 2, phase 1, the only construction that is happening is finalizing that temporary southbound pavement. We weren't able to get at all of it in the previous stage because, as you saw, we had that massive 1.5 to 1. We had this big 1.5 to 1 slope coming off. So we weren't able to build all of the temporary pavement here and box culvert and maintain traffic. So there was this little portion of gray pavement here that we needed to wrap up of temporary pavement. Then we go on to stage 2, phase 2. So southbound was already shifted in the previous phase. Now we shift northbound over to meet southbound. So we put everyone on that temporary pavement that we built. What does that look like from our awesome drone photos? So here you can see this temporary pavement. So starting right here at 27th Bridge, this view is looking south. We have a temporary ramp from 27th connecting over to that temporary bypass. All traffic is now on in northbound and southbound directions on the temporary bypass. We have 2 lanes in each direction now. So that was a big benefit of being able to provide better access and reduce delays. Then, so the western portion of the box culvert is complete. You can still see they have the sheet pile in there. We had to build some temporary moment slabs. So these are just for a temporary configuration. We put in moment slabs to protect this box culvert construction because the last thing we wanted is an accident in this area. Now we're building the middle portion of the box culvert. So we built the west side, we built the east side. Let's connect them in the middle, and that's what's happening in this picture. So we provided a large pull-off pad for deliveries and trucks to get into and out of this work zone. So they come on existing northbound's road bed, come up along this little pad that we built for them, and then that way they can get into and out of the work zone. And it actually kind of looks like they made their own path as well. So that's there. Then, like I said, this little bubble bypass that we built and weaved between all those bridge piers, they ended up demoing all the bridges. There are no bridges there. So the contractor, as part of the CMGC process, reached out to MnDOT and said, I think we can better this and actually build more of the Miller Coffee Creek realignment. And so MnDOT reached out to us and said, let's look into this and see what we can do. So Alliant worked closely with MnDOT and the contractor to figure out a better, more direct alignment, but also we'd already built the moment slabs on southbound. We'd already built all of this temporary pavement on southbound. So we didn't want to go back and tear out some work that we did just to realign this. So we kind of tied into what we had on Lower Michigan already built. We tied into what we already had on southbound already built and realigned and redesigned that bypass to be a little more smooth. And then with that, we were able to complete the Miller Coffee Creek. So right now, Miller Coffee Creek comes down the hill and goes into the existing box culvert here. Now it's going to be conveyed underneath a pipe under 22nd Ave and then through a creek to get to the box culvert. Okay, so here, like I said, this is where you don't realize all your traffic when you're driving up there today, coming down southbound, all your southbound traffic shifts onto a local street that's lined by barrier, drives on a local street for a while before it connects back up to 35. And then northbound traffic is on the existing southbound low-level bridge. So here's the old northbound bridge that we're demoing on the right side. Then we go to a winter configuration. Just gonna skip this. Traffic's still in the same location. We just opened up a ramp here. And then the last stage is stage 3, phase 1. So this is where there's kind of a hybrid of this, but this is essentially where we are today in construction. So the Ames Kramer joint venture is working on northbound pavement right now, or northbound construction right now. All traffic is still on that southbound bypass. So southbound's on the little bubble, northbound is on southbound pavement adjacent on the southbound low level bridge. And then when you get up to the north end of the project, they all shift back over to their existing lanes. That should cover work package 1, and now Brett's going to go through the remaining work package 2, 3, 4.
All right, thank you, Nicole. We will go high level because I'm sure that people's eyes are starting to glass over.
What are you talking about? That was really exciting.
For us. All right, so I guess so one thing that's going to be coming up this season, as long as funding goes through and the CMGC is able to is successful in bidding this job, is the actual adding in work package 3 and 4, which would be adding in the Garfield area, which is the interchange down to the south. So it's right before the Blatnick. So it's in this area. The Blatnick Bridge is to the left. In this area, we've got to reconstruct this whole interchange in addition to the main TPI interchange that Nicole was talking about. So what we are going to do is we're going to take the first initial parts of it was just to build a temporary ramp that goes through a couple of the existing ramps. And to do that, we're going to take traffic down to a single lane and then make them all exit the ramp. And then as you can see, let's see. And then on the main area, the main interchange, it's really just picking up where Nicole was at. So it's building all this traffic is still where they were, still southbound's on Lower Michigan, northbound's on the low level bridge. One of the main challenges we had here, and I'll dive into this a little bit, this will be one of the last minute details we go into, but it was really challenging to build proposed northbound at the same time as the southbound existing low level bridge was in place and still active. So we needed to build, and I guess the other thing we needed to build is it's called an LTP, or it's a load transfer platform, which is essentially like a land bridge. So it's something to protect, or I guess build a solid structure to build all the grading above. So that, I mean, really it's just horrible soils out there. So we needed to build a big platform underneath the ground that you could build the fills on top of, so that it's not a bunch of bridges again. So I put a couple cross sections in of that challenge. So what we did to analyze that is, this is a better one actually down here. So you can kind of see that this is the existing road, or the proposed road that we're building here. Here's your LTP, or your load transfer platform. So it's just, in its essence, it's a huge slab of concrete with H-pile that goes underneath it, so that all the loads of the entire road and fill can be supported by that on top of really bad material. So we need to be able to build the load transfer platform at the same time as we need to build a chunk of southbound and northbound to support future phases, while the existing bridge, which I just put in red, is one of the existing bridges that has traffic on it during this construction phase. So we needed to look at as like the existing bridge goes to this blue line. We needed to say, okay, to be able to work and demo this bridge and build, we need to have a minimum of like 3 to 5 feet off of the bridge to build the load transfer platform. Because remember, they need to drive sheet pile, or not sheet pile, they need to drive H pile into the ground to support the load transfer platform. So they needed 5 feet between the existing bridge and what you're driving pile into the ground. And then we also though needed the LTP to stick out from the existing or the proposed road enough that you could grab onto it the next phase and build the rest of it. So we did an analysis of all the cross sections saying, okay, here, green line, we did this on all the cross, every 50 feet. We said green line is the minimum we needed to build to support traffic control in the next phase. We said blue line here, and this, so this was the extent of the LTP. So the LTP needed to be built beyond this blue line. So somewhere in this area is what the LTP needed to be built to. Red line is cannot build beyond that point. The LTP couldn't be built beyond that point because it was too close to the existing bridge. So we went through each up one of them to look at that to see where we could build the temporary wall. And you could see further up, we actually had an existing bridge was still in place. And I'll show you a plan view of that, but we needed to maintain that. So we were actually cutting off a chunk of the existing bridge to then build the LTP and enough pavement. So again, it was getting really close down to like a couple feet between, the maximum we could build for LTP and the minimum we could build for LTP while still staying off the existing bridge. So that was kind of a little tricky thing. In the plans, we ended up showing a detail like this. This is the bridge cut line. We needed at least 5 foot. You could build a 2-foot wall, and we needed to build some temporary fill behind our proposed barrier to make sure it didn't slide on us. In the plan view, again, we kind of graphed out all those lines, minimum LTP line, in place bridge line, red is maximum LTP. So it was fine back here, but you could see when we got in here, this is all one big bridge. So we had to create a bridge cut line, still looking at the greens and the reds for the limits of the LTP. And I think this kind of shows, Nicole took a shot and put this in there. This is kind of the removal of that cut line for the bridge. So that's what you're seeing there. So, all right. So then the other things that we did, I think that's kind of it for that one. Obviously, with this phase, assuming that the funding comes through, we'll go and build TH53 up the hill. Next stage, so back down to Garfield. At this point, we took all traffic off of the Blatnick Bridge, took them down to a single lane, had them exit. So it was a reverse curves down to the existing Garfield. So Garfield becomes the main thoroughfare to and from Duluth to the Blatnick Bridge. One little thing, it's not too innovative or anything like that, but one thing to think about for future traffic control things, we actually closed the left lane first. So we slid them over to the right lane. In essence, we were afraid that people are gonna be flying down the Blatnick Bridge too fast and then hit our 30-mile-per-hour reverse curves. So what we did is first we put a ton of signing out there. So if you count, there's 9 different signs for speed limit or speed reductions throughout this whole thing. So, and then what we did is we closed the left lane. So we shifted them over to the right lane. We actually put barrier there to also support the fact that that left lane was closed. Do not go through. This is going to be up during the winter. So we closed it down, shifted them on the right, then did a 30-mile-per-hour shift to the left. Again, because I'd rather have them, if they're going too fast, I'd rather have them go into this dead area than to go and hit our reverse curves too fast. So then, we use reverse curves to bring them back. We intentionally put barrier on both sides of them to just put some restriction so that we could kind of almost spook people into slowing down if they're going too fast again too. So used a bunch of different methods to try to make sure that people slow down before they hit 30-mile-per-hour reverse curves down to Garfield. And Garfield itself is 30 miles per hour. So they're going to be that speed anyways shortly. But yeah, so in this phase, in the main interchange, what we did is at this point, we did finish up the whole LTPs for northbound. We built a bunch of southbound too. So at this point, we flipped them all onto the proposed northbound or temporary widening. As you can see, 2 lanes in each direction, kept them going through here, crossed them back over. So onto just northbound. So in this area, it was really tight, especially underneath the green T. So we needed northbound and southbound. We couldn't do any temporary widening or anything. And there just wasn't extra width. So we needed 2 lanes in each direction through that area. We crossed them back over. So at this point, we were on just proposed northbound and that we were able to fit 4 lanes through there. In this phase, we were also dealing with the girder sets. So we needed to go and set these girders, and these girders, and deck pours over proposed. So that was tricky. In essence, in the name of time, I'm not going to go through those at this point. Reach out to me if you want to talk about girder sets. Next phase, as you can see, with Garfield still going on, down in the main interchange, still crossed over. Really, the only thing that is difference between the previous phase and this phase is that we closed the southbound area through the 27th area, 27th interchange, mainly just because we tried to limit the duration of closure for that southbound exit ramp, because it's not a good, there's no other real good way to exit there besides going way down to 40th to the south. At this point, now we've got a winter config, so we actually have northbound on northbound, southbound on southbound. Still some closures that are going on, mainly due to temporary configurations. We weren't able to build these. We still got little plugs throughout this whole thing. We still haven't built the outside shoulder on southbound. So because we haven't built the southbound outside shoulder, we decided that it made sense to try to not open some ramps, especially coming from 535 to the southbound, with we've got temporary configuration here. So just keep that ramp closed for a little bit longer. Southbound from, let's see, at this point, 53 is still being built. So there's no point. And obviously those ramps can't be open yet. So, but in general, by this winter, Garfield is all opened up and mainline for 35 and the main interchange is done. Spring of the final year, we go and just at Garfield, now we can mainly keep most of the interchange open, but we do have to close a couple areas just to finish up a couple ramps where that temporary bypass used to be coming through. So that's why these things couldn't get done, because we had to maintain the temporary bypass. And we just do a lot of cleanup. So we're removing crossovers to the south, building in that outside shoulder on southbound in this area, reconstructing Lower Michigan. And then there's a couple other little short phases we're not going to go through to clean up this Gore area, clean up a couple other crossovers here, remove this temporary widening on the outside, do that type of stuff, finishing up 53. And then finally, we are done in the summer of 2025. That is the phasing and staging of the TPI interchange. So with that, I'll go to the outro. So discussions, Q&A, if there's any questions, throw them at us. Otherwise, thank you very much. I'm Brett, that is Nicole.
Thank you. So I didn't see anything come through in the chat, but if folks do have questions, now's the time. I see Paul's got his hand up. So Paul, go ahead and unmute yourself and ask away.
Great. Thanks, Justin. Well, great job, Nicole and Brett. Definitely great presentation and very impressive work. Just a simple question here. I was curious what the experience was like working with the city and the public to get approval for using Lower Michigan, as the, to actually run mainline traffic on that, and if there were concerns, from the neighborhoods or the community there.
Thankfully, MnDOT handled that. So I think it kind of came down to the fact that there wasn't a lot of, like you can see, there's just not a lot of room up there. So the good thing is that in the Lower Michigan and the Lincoln Park area, that was a kind of a street that was sticking off a little bit, so that you still had Superior, you still had other roads in that area. You had Michigan, you had Superior, that could keep that connectivity in the neighborhood going. So just the fact that by keeping 2 lanes of traffic going through that area, it kept traffic off of the local network as much as we could. So I think it was just seen as a net gain for the project. So I did not hear a bunch of pushback. I'm sure there was way more than I heard, but thankfully we were filtered from that.
Some things that we did, and I think this might have come from the city, is we put temporary barrier along both sides. So we also put in a fence on the city side. So along that whole entire stretch that we put in a right-of-way fence, so that, Bent Paddle is right off of Lower Michigan Street down there. And so there was a lot of concern of people drinking and trying to get into the work zone. And so we put in a right-of-way fence along that whole stretch.
Yep.
All right, thank you.
Thanks, Paul. Any other questions? I see Ken's got his hand up. Go ahead, Ken.
Yeah, thanks. Thanks for the presentation, Brett and Nicole.
Yeah.
We are just curious about just kind of the public outreach efforts, and maybe that was handled by MnDOT, but could you just comment on, you try to spread out traffic and make sure that no local street was going to get hammered and whatnot, but what was the public outreach efforts like that about anyway? And I'm assuming that it was handled by MnDOT, but if you could comment on that, that'd be great.
Yeah, yeah, I'm not gonna be able to provide much or else. It truly was like MnDOT, Roberta Dwyer, Caitlin Johnson. They're the ones that were sitting down with the cities, you know, obviously very regularly. There were others. There were city improvements going on with this project too, like water mains and stuff like that, and some city street improvements. So I think that they were a partner throughout this whole thing. So that really obviously helped when they had a stake in the project too.
Sure. And did,
They did in the final design, I know something that they did is they had a real 3D model of the final interchange that they took up there to a bunch of open houses for the public to kind of show them and get them excited for what the final product would look like. And so I know that that was something kind of fun that they did from the final design perspective for public outreach.
and what was the one other question I had? It was the, I know that Centrax is used by the city of Duluth. Was that incorporated into any of these plans that were being developed?
I honestly don't know what that is.
The ATMS, the software connected to the signals. So
Okay.
was signal timing like adjusted or monitored or that kind of thing during the project?
Yes, for sure. So Alliant actually had a separate contract through with Mike Anderson that they were doing signal timing for each stage. So he was working with Nicole and I to figure out, okay, what closes when, for how long, what else is closed, so that they could kind of come up with pre-planned timings to implement whenever we switched to do new stages. So they were actively involved and they were customized timings for each of the stages, especially along, you know, Masaba and Central Entrance. That was a huge thing up there.
And we deployed a couple temporary signals for the project too.
Yep.
If we were heavily overloading, like up at Piedmont, we placed a temporary signal while that detour was in place.
Yep.
Do you know, just out of curiosity, what like I don't know. I've seen a couple of temporary signals around, but do you know many details about the temporary signal or the signal that went up?
I
Just
know
like
Joe Biden drove through it.
I think they're pretty simple, like wood pole span wire.
Okay, all right. So it wasn't like a easily movable one. It was just a
No.
it was a standard temp signal.
Yeah, they were. I
setup.
mean, they were
Okay.
in place for years. I mean, there's one of them that'll probably in place for 4 to 5 years. So.
Mhm. Okay. Yeah. No. Thanks.
Yeah.
Thanks for the presentation as well.
No problem.
Any additional questions? Go ahead.
Hi, this is Amy Marone with City of Bloomington. Sorry
Yes.
to keep along the train of the local agency questions, but you know, there's a lot of traffic that, you know, if you're going down to the 2 lanes in each direction. Was there unexpected cut through traffic in the local roadway networks that had to be mitigated in any way during the project? Were you guys involved in that at all?
All right, we have not heard anything negative coming out of it. Is the simple answer I have. It's if there have been problems or anything like that, it definitely hasn't gotten back to the designers. But I mean, the way that CMGC kind of works is it is more of a traditional delivery once it goes into the construction phase. So the DOT will reach out to us if there's a concern or questions, and we'll adjust things or tweak things as needed. But I think, just driving through myself, the one thing that's nice about the project and the way it is, so in general, we tried to keep 27th interchange open to the south, which is a good access into Lincoln Park and everything. But also just by keeping 2 lanes of traffic through there, like the congestion itself, like you went from having, you know, the can of worms that had just all this, you know, the traffic disruptions and slows and crashes and all that stuff, to just being a 2 lane or 4 lane divided road that just flows smoothly through it because there's no interaction. So I think through traffic actually probably flows better now than it ever has. So, and then I think that the locals have just all, at this point, things have been closed for quite a while, and they've all figured out these are where we go and these are where we don't go. So whenever I've been up there, it's been pretty smooth. So.
Great, thanks.
Yep.
Mike, go ahead.
Can you talk about the intelligent work zone and other technology that you implemented on the project?
Nicole, you want to talk about your little thing again?
Oh, my intelligent work zone.
Like-
But our intelligent work zone had a queue detection system on the south, I know in the northbound direction, so south of the project, that had time, I believe, had PCMS with like our time delays. Other than that, I mean,
It's not a lot, Mike.
Nicole, this is Maury. Do you want me to add? 'Cause
yeah, if
we
you could,
tied
Maury.
everything. Yeah, Mike, I can expand. We tied our existing ITS, bunch of our message boards going northbound into Clear Guide to give us travel time delays and went for stop traffic. So which is nice that Iris and Clear Guide talk to each other now. And I know statewide we've been doing that more and more too.
Great, thank you.
Thanks, Maury.
Any staging questions?
I'll ask you guys a question.
Sure.
What have you used any of the techniques or like new ideas that you came up with for staging in other projects since doing TPI? Like some of the new ways that you have figured out how to move traffic. Have you implemented that in other projects?
I would say in general, every job is different. So the thing is, I don't think there's ever a job that you can take one staging approach and purely apply it to another project. So I think but what you do is that each job you do, you learn, you get more tools in the tool belt so that you can go to the next job and kind of tweak things and adjust things and just kind of find the right approach for each job. So specifically, nothing has been applied, but in a way, everything has been applied. Paul, you got another one?
Well, Brett, since you requested a staging question, I thought I'd try to something there. One of the things you showed that I thought was interesting was, earlier on when you had kind of mapped out the different options for each phase or sequence, you kind of had like the red, yellow, green matrix of the pros and cons. And of course, at the end of the day, there's no such thing as a good work zone, right? I mean, Minnesota winter road construction.
Yep.
But some of those stages presumably are like better than others, right? Where you can mitigate it and achieve some, level, and others that you probably know are just going to be tough. Is there any kind of, I know it's more of an art than a science maybe, but kind of trade-offs or thresholds beyond which, if it's just going to be a stinker, in terms of the traffic impacts that MnDOT, would request, or you might propose doing something, a little bit more, or, is there expectation, you meet some sort of minimum quality at each stage?
No, I honestly, a lot of it came down to, in the end, like when we were going through that exercise, like we as a team identified what we thought was like the best detour for each closure. And we wanted to do those, and we kind of were going down that road, but at some point we actually kind of called a timeout and said, let's back up a little bit and say, ultimately though, does it really, if we've got a better detour for let's say 27th Avenue southbound exit ramp, let's say we close it for 27 months in a row, and each phase has a little bit different detour that could be better. Does it actually make sense to change it? Or does it make sense to find a good detour that's going to work for it, and let's leave them sit there for a decent amount of time, just so that people can get used to it? And that's actually where we then pull back and said, oh, you know what, let's use, at first we were not using Mesaba and Central Entrance much. It was a lot more like local roads and systems in there, and same for the Brong Bridge. But then we realized that, you're going to cause more confusion by trying to change the detour all the time than we would to just say, you know what, let's get people used to this configuration and then let's leave them, because ultimately once we got into this job, 53 closed, 535 closed, 27th had some closures, and it just was what it was. So you put in some good detours that were easy for people. They might not have been the shortest, but at least they stayed consistent, and people not familiar with the area could get on them and follow them without a bunch of right turn, left turn traffic, where they had to think about a bunch of stuff. Just follow the detour, you'll be fine. So I think that in the end, it's kind of like this job logic overrode a lot of stuff, because you had to close a bunch of stuff. So let's make it easy for people to understand when they're in the field.
Oh, that makes a lot of sense. Thanks.
Yep.
It was nice to have the contractor on board too, because as we're talking about reducing lanes, getting real-time feedback from them on duration of construction, and minimizing the duration of those lanes being reduced in each direction, as well as establishing kind of a schedule, right? Like this stage will go from X date to X date, and making sure that once winter hits, we have as much access as possible open, so that we're not creating even more fatigue on the drivers and plow drivers and everyone in the area.
Yep.
All right. I'll open it up, I guess, if there's any final questions here from the group. Otherwise, we can wrap up. Not seeing any other hands. All right. So yes, thank you, Nicole. Thank you, Brett, for your time in the presentation. It was very informative. We got some good questions here as well. So I hope everyone enjoyed it. I do want to give one final thank you to our sponsor as well, which was Traffic Control Corporation. So thanks to them as well for sponsoring this event. And we look forward to seeing everyone at future events.